We have been talking about how to calculate the number of lighting points in an installation. So today we are going to do a summary. I've given you a lot of notes. I don't know if you guys do go through the notes. I've given you a lot of notes of the formulas that are involved, the height, the distance. When we will come back to school face to face, we'll be able to review some of the calculations that we could not be able to clarify well online. So today I want us to go through an overview of the general requirements when you want to do a layout or a lighting and power design layout. So I'm maximizing the screen so that we can see it well. Now, lighting guide performance and lighting guidelines. So all internal and external lighting shall be designed to enhance safe movement, personal safety, and security. So the following are the lighting categories in accordance to the standards and shall apply in following nominated areas. We normally have lighting points in bus stops. We have lighting points in areas adjacent to the entry or exit. That is 5-meter radius from the entry or exit. These are type P6, these are type P10, these are type P7. Remember, we talked about the different types of lighting points. We also have general ground adjacent to areas such as night activities and entrap spots. This is besides the residential houses and commercial houses. Remember, we talked about when we want to calculate the number of lighting points that are needed in a room. We have to consider the height. We have to consider the purpose of the room. Like, for example, a classroom will have a different number of points with a residential house. Like now, a 3-bedroom house or a 2-bedroom house, it will not have the same lighting points or criteria for. Or a workshop. A workshop has a lot of lighting or illumination simply because it has to be have enough lighting to avoid accidents. So each type of room has a different function or a different lighting point criteria. So the design requirement, we have the luminance. All luminance shall be manufactured from the components. This can be from any company, not just specifically Australian made components, where possible, and be approved by the electricity authority. So all luminance shall be supplied complete with lamps and fused terminal blocks, and then the spring loaded and then the lamp holders and so on. So single lamps generally shall be installed. However, dual lamp luminance may be used for the high ceiling that occur or the high lighting levels. So even in residential houses, we have lighting points that have high levels are installed at high levels, or the ceiling is very high. Like now in theaters and workshops, they have very high ceilings. Like now the industrial areas, like now the mezzanine floors, normally the heights of the room is very high, and the lighting points that are installed there obviously are different. Obviously have to be different. And now we have I proceed. We have fluorescent lamps shall be of the light high efficiency type, incorporating the high frequency, the warmth, the soft start. That is Osram. That is a code for a trademark for the factories of or industries that generate or that manufacture this type of lighting points. So all luminance shall be adequately ventilated. Temperature rise in the fittings should be restricted to 50 degrees Celsius above the ambient temperature. Okay. Let me proceed to the next slide. So the installation of the luminance okay, the installation, let me zoom out again. Installation of the luminance with the T5 lamps shall only occur with the express agreement of the superintendent, that is the diffusers, to T5. These are the types of luminaires. And remember, we talked about calculation, being able to know the number of lumens, then the lux of a specific light fitting. So the length and type of luminance shall be suited to the ceiling module and or location of the installation, where existing fluorescent luminaires are to be reused. All approved for the non-electronic ballast has been given. So the luminance shall incorporate status of the non-flickering warm soft start electronic type, the power factor corrected, and B switch start type, complete with fuse, terminals, blocks, and ballast. So luminance design and layout should satisfy the intensity, glare, and uniformity requirements of the open offices with sufficient flexibility to enable partitioning of the individual perimeter or the island of offices. So when we are designing these luminaires, we said it's lighting points. We have to take into consideration the intensity, the glare, and the uniformity. The uniformity meaning if the distance in between the lamps is 20 meters or it's 5 meters, it has to be uniform throughout the room. The luminous design and layout should satisfy the intensity. That's what we have said. So the fluorescent tube lamps shall be the Osram Lumen Lux plus the Echo. That is the Philips. This is just a specification, which is the best types of fluorescents that are in the market. Then the light selection be limited the types of current used. Now we have the wattage. For the fluorescent, we have if it uses 36 watts, that is T8, and this is the temperature in Kelvin, that is the now these normal energy savers fluorescents that normally come with, some of them are coiled, some of them are strips. We have different of them. Then we have the metal halide discharge lamps also. External lightings shall be discussed with the superintendent. Now rods and parts, these are the types of electrical services that are needed. So what are the light fittings that are used in the auditorium, lecturer theaters, seminar rooms, teaching spaces? This space or the like shall be provided with illumination complying with that standard. Then we move on. Now the control of the lighting, that is the controls, the switches that are needed. So I'll go to another slide. Now the general purpose of the power outlets. Now the power outlets, these are normally the socket outlets. Most of the time we also determine or want to calculate the types of power outlets that are given. How do we calculate the number of power outlets or the power outlets that are given? So socket outlets use a dual, that is the 10 ampere single phase switched socket outlet in all locations that call for general purpose outlet. So the GPO is GPOs are that just the general purpose, means general purpose outlet, unless nominated otherwise. So whenever you see the initial GPO, just know that it means a general purpose outlet. So special purpose outlets are the Cripsol. These are special purposes, like now the clean power that are normally used in special workshops. Access control, kitchen presentations. So I'll be able to give you this notes so that you'll be able to see. Video conferencing rooms, they provide the following general purpose outlets, that is 4 in number, behind the equipment track. These are just a simple way of designing or being able to design the number of lighting points at a point or in specific areas. Okay, switchboards are there and the test points. The distribution boards. The distribution boards are given a certain type and should provide 100% spare capacity of all distribution board. And then all lighting power points can be loaded to less than 75% of their rated capacity. So we will go into details on the calculation and the loading and calculation of the loading. The labeling also should be very precise. So I'll bring another slide. So we are doing the electrical design plan. So when we are doing this electrical design plan, remember we did the calculation. We did the calculation of lighting points, and I said we'll repeat those calculations when we come back to face. We did the how to know the number of lighting points in a room, and sometimes, for example, you are not on site. When we were doing the generation of the bill of quantity, we say that when you have you are designing a bill of quantity, you have to have some rough estimate. Like, for example, you are on site, or a client comes and tells you that right now I have a 3-bedroom house. I need you to give me the material, the total material, the cost of the material and labor that will be needed to be able to complete the task, or that will be able to finish the task. What do you need to do? You need to do a lot of things. You need to know to calculate. Remember when we were in school, I gave you a certain formula for calculating the amount of cables that you might need, that is, and the power point, meaning you normally take the height, that is the distance between one point to another, to be 20 meters. That is an approximation that will never fail. So when you're designing a plan, you need to have a lot of things in mind. You need to have to know what is the use, what is the purpose of this room. That is, design the process, understand the project scope, and defining the parts of the electrical plan, then determining the application standards. So in all buildings construction or all remodeling building projects, the owner or occupant must first have the concept of the new design, and then the architect or designer can produce a set of building plans. That is, these plans convey all the required information to the local inspection authority and associated building trades, so that the construction or remodeling can take place. So because commercial and industrial buildings contain a number of electrical systems, these plans include specific electrical designs and additional documentation to verify the design, that the design conforms to all required building codes. Now, a designing process. An electrical design goes through several important stages of development. That is, first, the designer must understand the scope of the project, meaning you must understand the scope of the project. And then the designer defines the design, each component, such as general office areas, specialized machinery, and power distribution equipment. That is to recognize industry standards. Finally, these individual components are compiled to form the final presentation of the design. Now, understanding the scope of the project. How do you understand the scope of the project? Now, electrical design has unique requirements. Electrical design has unique requirements depending on the scope of the project. Now, the project scope is determined by the customer's requirements and the type of structure that the customer will occupy. Now, for example, if the project requires a new electrical system for an existing building, then the electrical designer works to incorporate all the new electrical wiring into existing system. Now, this designer must evaluate the existing electrical system to ensure that existing electrical system can accommodate the new additional electrical loads. Meaning, when you're doing electrical design, you will be engineers on site and you will be given these jobs to do the design. Then you ask yourself, what do I need to do? As an electrical designer, you have to understand the project scope and determine the customer's requirements. Maybe the customer tells you that I need this type of wiring. I need this room, I'll use it for this. This room, I'll use it for this. So after getting that understanding, you'll be able to know the type of fixtures that you'll be able to propose. So the designer must evaluate the existing electrical system and ensure that the electrical system can accommodate the new additional electrical loads. What if the building is a new building? Then you're the person who will be able to calculate the loads. You calculate the maximum ever loads that such a building can carry. If it is a story building, you have to supply it with a three-phase because there can be additional loads with time. So it doesn't mean that if the building is starting with a few loads, it will not add. Or if they are commercial building, you also have to supply it with a three-phase because somebody will come there with a welding machine, somebody will come there with a posho mill. So there will be changes in future. So you'll have to give the maximum probability load provision so to enable the client to be able to shift the loading as required. So when the design is for a new or proposed facility, then the scope of the project is much greater. That is, electrical design of these types of projects require an extremely new electrical system design. And this new electrical system design is normally generated by an individual person. Now, depending on the overall scope of the project, a design can include the following components. That is the general electrical requirement, e.g., the general purpose receptacles. The general purpose receptacles. Okay. Now, specialized electrical equipment, e.g., the specialized office equipment on machinery, lighting system, electrical distribution systems, and so on. So the general electrical requirements. We have the general electrical requirements should be defined first on any electrical design project. That is, the general electrical requirements are items such as the 120 volts general purpose receptacle outlets located through out the commercial and industrial building. So these receptacles are usually not specified to serve any particular load, but rather are for general purpose. And that's why we said they're called general purpose outlets. General purpose outlets are not specific for individual load, but they can be used all across everywhere. Okay, so status wall receptacles and desktop computers equipment with no special electrical requirements. So specialized electrical requirements. So don't forget also that there are electrical requirements that need special electrical power. That is, certain projects may include a specialized electrical requirements that require separate or dedicated electrical circuitry that serves only the specialized equipment. E.g., these equipments may be of the following types, that is, the computers and or network servers, the photocopy of microwave ovens and other lunchroom appliances, and vending machines. Remember, these are machines that use very high power. These are machines that use very high power, and they are used there specifically for that. I hope you're still getting me. Now, because of the electrical load requirements, as per the manufacturer's requirements, these pieces of equipment may require individual circuitry and special grounding methods. So now this is an example of a specialized equipment or electrical requirement, not like a photocopying machine. Now we have lighting systems. Because of their complexity, lighting systems are the part of designing process that generally requires the greatest amount of time to develop. Now, these systems include all the lighting fixtures and their controls. Lighting systems have very detailed requirements as per the standards and require documentation showing the system incorporates all the required energy-saving technologies. And then the distribution systems. An electrical distribution system is an installed equipment that provides for the distribution of electrical wiring throughout the facility. That is, it includes the main switchboard. This receives the power from source, then serving the utility and all the associated components such as the panel boards and distributes all the required branch circuits throughout the facility. Now, parts of the process of designing the distribution system is calculating the facility's amperage. So we have to be able to calculate the amperage, that is the loading, and the short circuit values. These calculations determine the total electrical energy that is needed. So you can see this is a lighting system that are most complex part of the electrical design. You can see how this room is illuminated. So you can see this is an electrical distribution system that provides power to the entire facility. This is a good example for a generating station that has very huge distribution boards, or an industry. There is a distribution board distributing power to different branches or different parts of the industry. Now we have a history calculation determine the total electrical demand requirements of the facility based on the individual parts of the electrical distribution system. Now, determining the applicable standards. How do we determine the applicable standards? So once each part of the design plan has been defined, the next stage is to design each part of the industry recognized standard as well as the additional standards set forth by the local jurisdiction for commercial and industrial occupancies. So the primary industry standard is the National Electrical Code published by the National Fire Protection. It is revised every 3 years and results in the publication of the new edition. Is applied in the national level, that is, some local jurisdiction may have additional standards that exceed the requirements of the NCE, or they may use the previous edition code. Now, for projects based on the national templates, such as is often the case with retail outlets and fast food chains. These are now other special facilities that need special installation. Now, the requirements of adjustments that are necessary to conform the local code requirements should be documented in the final plan in the general notes section. Now, please note that only official documented standards may be enforced, not widespread and official community practices. They are normally the only thing that is documented is the standards, and not just things that are normally used on the ground. So some projects will also have additional requirements based on their specific components, such as those including specialized electrical equipment. So an electrical designer should always consider manufacturer guidelines for specialized equipment and the use of appropriate electrical equipment standards set forth by the manufacturer for overcurrent protection sizes, specialized grounding requirements, and so forth. So these specialized requirements may require that additional specialized wiring practices be observed. So when this is the case, this specialized requirement must be documented on the plan. Designers must also consider the standards of these. That is the National Electrical Maintenance Association and so forth. There are so many other bodies that need to be considered. Now, creating an electrical plan. As electrical engineers, at this point, you're supposed to be to have used this CAD. CAD is called it's a software called a computer-aided design. So once various parts of and applicable standards have been determined, the designer begins compiling those parts to form the electrical design and complete the set of plans. So historically, these plans took the form of hand-drawn blueprints, but today most plans are created digitally using the computer-aided design software tools. So digitized plans are easier to revise and transmit than those drawn with pen or pencil. So these days we do the digital plans. These days we do the digital plans. Now, when printed, a digital plan are typically produced or engineers like I don't know. Did it disconnect? Salad, confirm you're getting me. You're getting me. Okay, we proceed. Okay. So I was talking about the electrical plan. CAD is the software CAD is the easiest now way of planning that we have currently. It is the one that is most suitable, or the most suitable plan that is used in the current world. So what do we do about the plans? When the architect gets the plans or gets the idea from the client, the architect comes up with a prototype. That is, this is a sketch of what the client needs. So after doing the sketch, he now does the CAD. He uses the CAD, that is a software that is used for designing of electrical building. So he uses the CAD software. After the CAD software generates a plan of what is expected. So he then forwards this plan to the electrical engineers, again to the mechanical engineers, to be able to understand the building. So the electrical engineer receives the plan from the architect and now tries to put in power. So before the electrical engineer can be able to put in power, or can be able to power the circuit, or to power the diagram, they have to understand the scope. Remember, we talked about understanding the scope. They have to understand the scope. In understanding the scope, you need to know what is the work of the room, of the building. What is it going to be used for? Is it going to be used for residential? Is it going to be used for commercial? Or is it going to be used for a workshop or an industry? So after understanding the work or the use, then you will calculate the loading. You'll know that it's for in an industry, the maximum load that can be needed in such an area is this amount. So the design is done and inserting the PowerPoint. I think when we were in school face-to-face, I showed you some of the designs. So this is a traditional blueprint. This one now, they used to do this with pencil. You can imagine how hectic it was doing this drawing in pencil and making sure that you can be able to understand. And these were called the blueprints, which were very hectic at that time. So these are the symbols that will appear, the electrical symbols that will appear when you are doing the design. So this is for the single receptacle or the single socket, the duplex, that is the double, and sometimes these are not constant symbols. The symbols will change depending with the site, or depending with the codes of a certain country. And remember, we used to use a different type of symbol for the socket, and you can see this here. So when you go on site, there's normally, when you're doing the design, you have always to give something called a key. This is an example of a key or a list. This list will show you the fixtures, or we will be able to show you. We normally don't have a standard key or standard symbol or representation or international symbol representation, but each contractor or each designer can use a different, provided you just show that if this is a conduit installed concealed, then we have to use that and indicate. Conduit installed exposed, you can see that. Then conduit installed underground, you can see. So all these switches are here. The symbols differ from one country to another, or from one designer to another. List of the attached final design. Occasionally, the need may arise for the symbol that has not been developed, such as a symbol for a newer energy saving or energy management device. So in this case, the designer may create a new symbol for the electrical design plan as long as it is added to the system, the list. Okay. Also, the electrical design plans may be included in the separate document within the complete set of building plans. So to identify the electrical plans, each page of the electrical design plan is labeled with the number of numbered as maybe electrical plan 1, plan 2, plan 3, and so forth and so on, depending on the sheets. So electrical sheets are generally presented in the following order, that is the exterior electrical site plan comes out. So these things are normally printed separately. The sheets are normally printed separately. We have the interior electrical plan, interior lighting plan, that is the power plan. It's not put together with the lighting plan. I'll drawings that have already been done. And then the documentation, and that is such as the panel schedules, electrical calculation, single line diagrams, and lighting system energy requirements. The number of electrical sheets required for a project varies based on the amount required information that each project requires and how much of that information can fit on one page and still provide for a clear, concise, understandable set of prints. So master concepts, some of the concepts that we should never forget, that is when designing an electrical plan, a designer must understand the scope of the project, that is define each required part, and then design them in a recognized industry standard. Other parts of the electrical plan, general and specialized electrical requirements, lighting system, and electrical distribution system. The electrical plan must be designed to recognize industry standards, that is, use appropriate electrical symbols. So you use the electrical symbols that are understood at your area. And then once the various parts of the applicable standards have been determined, then the designer creates a complete set of plans. Okay. So you can check your knowledge here. Each of the following parts include the electrical design, that is the general specialized equipment load, lighting system, distribution system, or all of the above. So these are things that you can later be able to find out by yourself if you have been able to understand. So up to that point, I want us to have some questions. So unmute your mic. Unmute your mic so that we may wind up. Yes, Salad. Any question?
Yes.
Any comment?
Yes, class good and enjoyable. But bona nimeshinda kuingia na laptop.
Kwa nini umeshindwa kuingia na laptop? Umeingia na simu?
Nimeingia na simu, nimeshinda na laptop.
Na mimi nimeingia na laptop. Ama leo hujaingia vile unaingia kawaida. Si tunaingia na hii normal big blue button. Hatuingii na link.
Si iko tu kwa hapo poto, si ndio? lakini nimeshinda na laptop ndo nikaingia na simu.
Maybe ulitumia Chrome. Ulikuwa unatumia browser gani?
Chrome. Chrome.
I don't know, maybe you could have restarted. Unajua laptop saa zingine inaweza kuwa na issues. Ungeweza restart. Alafu nini? Alafu uone inafanya aje. Si sawa? Unajua we are almost finishing the syllabus. Nataka kusikia challenges zenye mko nazo because next semester I think kutakuwa tuna revision because syllabus naona kama tumemaliza. Alafu soon tunaenda ku create an online workshop. Kuna kitu inaitwa online workshop where you guys will be able to hizi vitu zenye tumekuwa tukisoma installation nini you will be able to be doing them online. Mnafanya kama hatutaweza kurudi face to face, you will be able to do. Kuna vile software itainstaliwa. So you guys you'll be told to buy some materials. So when we are doing some practical, nyinyi pia mnafanya hiyo side and we inspect and see that you are doing according to what we expect. So those who have not been joining the class, I don't know how they're going to survive in this online era.
Lakini corona iko naona corona inaendelea kuisha.
Corona inaendelea kuisha? Lakini sasa Ministry of Education haijatuambia tufungue. Si unajua lazima tungoje tufungue.
Mpaka Magoa aseme.
Mpaka Magoa aseme. So kama bado hajasema si hatuwezi kosa. Sawa tu kama nyinyi wenye mmemaliza kusoma, you know, next semester mkiingia tutakuwa tuna revise. You normally know that your last semester is revision.
Yes.
So tutakuwa tutaanza na we will make sure that we have covered all the past papers. So kwa hiyo online workshop what you guys will be needed. Sasa itabidi mnunue some of these materials. Unajua vitu zenye huwa tunapata kwa workshop. Kama for example hiyo ya emergency lighting. Na hiyo ya motor installation inafaa kuwa kwa nini? Kwa practical.
Yes.
Na hamjafanya ndio?
Ya estimation maswali ya hii unit estimation yote nimefanya.
Umefanya yote?
Bado lakini ya EMFD.
Lakini hizo pia ni kidogo, si ndio?
Nitaenda kufanya.
Na nani anawafundisha electrical principles? Ngao bado anafunza ama alitolewa hiyo unit ikapewa mwalimu mwingine?
Bado anafunza, alikuwa anafunza unit 2, mathematics na principle. Sasa amepeana.
Akapeana mathematics. Sawa. Sasa Kenya tutafanya revise. We will do a lot of revision. Revise hizo vitu na you guys will be able to. I hope you guys are enjoying the class. Watu wengine wanaogopa kuingia online, sijui ni kwa nini.
Sijui. Labda ni fees.
Fees ndio shida. Lakini wacha tu hope that hii corona vile tumeona figures zinaenda chini. You guys will come back to school na tuendelee so that you do exams. Ndio?
Yes.
Sawa. So I want us to break there. Write something there on the discussion. Alafu after tutarudi class saa 8. Si kuna class ya saa 8? Tutarudi class saa 8 tuone. But in estimation in electrical maintenance and fault diagnosis pia ni revision tunafanya. So today I'll look for a paper that we'll be discussing. So tell your members to join in the afternoon class. Sawa.
Alafu tunaweza pata attachment ya attachment letter.
Unataka attachment letter ya nini Salad na hujamaliza kusoma?
Yani from December. Si from December tumemaliza hata
from December mnaweza mkapata, na unakumbuka sasa hamjafanya project. Mnafaa mfanye project. So it has been a challenge vile mnaweza fanya project na hamko, but from December tutahakikisha mmepatiwa hizo nini. But mmepewa hizo barua. That is in case kama unajua NEC itakuwa inasema mnafanya mtihani siku gani, si unajua pia hiyo itadetermine tuone kama ni mtihani mtafanya kwanza. Si ndio swali lingine?
hivyo.
Sawa. Okay, we'll break for now and we will rejoin 2 for the other unit. Okay, so bye.